Dear students, here is the another numerical from the flywheel. Okay, let me read the question. The turning moment diagram for a multi-cylinder engine is drawn to a scale of 1 mm, that is equal to 600 Newton meter vertically, and 1 mm is equal to 3 degree horizontally. So I already told you the turning moment diagram is the turning moment versus crank angle. So if you take a graph and draw the diagram with the scale, here in the x-axis 1 mm is equal to 3 degree and y-axis 1 mm is equal to 600 Newton meter. Next, the engine is running at a speed of 600 rpm. Engine speed simply is given, which means n value, capital N, that is mean speed. Next, the speed fluctuation is not to exceed plus minus 1.5% of the mean. Not to exceed means this is the upper limit and lower limit of the fluctuation of speed. So simply coefficient of fluctuation speed will be 1.5 minus 1.5 will be 3%. Okay. Next, find the flywheel mass if the radius of gyration is 0.5 meter. Now this is the given diagram. This is a multi-cylinder engine turning moment diagram. So the very easy problem, because if you calculate the fluctuation of energy, you can directly write the formula mk square omega square cs is equal to maximum fluctuation of energy, so that you will be getting mass value. The only work is to find the maximum fluctuation of energy. For that we need what is the maximum energy, what is the minimum energy for this turning moment diagram. I already explained you in a theoretical part about this multi-cylinder engine turning moment diagram. The same way we will be solving this problem. Okay. Here, if you take point A, energy at point A is E. Energy at point A is E. The diagram, the cycle is completed at point H. So, energy at point H is also E. Okay. This line is known as mean energy line. Okay. For the continuous running of this cycle, this mean energy is required. As the same way, mean torque is required for the continuous rotation of the cycle. Okay, so energy at A and energy at H is same. So now we are going to solve all the point energies. First, energy at B. Here, this area is 52 mm square. This one 124, 92, 140. 85, 72 and 107. They all are mm square. So just calculate all the available areas. First, point B, you have E plus this area 52. E plus 52. Point C, you already calculate the E plus 52 for point B, and next this is the negative loop, so you have to subtract 1 minus 124. In the same way, if it is a positive loop, you just add. If it is a negative, you just subtract from the previous one. If in this way you will be getting energies at all the points. In the theoretical part itself, I told you which one is maximum and which one is minimum. Now you can directly see with the numerical value. Here for all the energies, this will be your maximum energy, U plus 52, and for all this will be minimum. Which one? E minus 120 will be minimum. You can compare all the values. Okay. Now, if you take the difference of these two, you will be getting the maximum fluctuation of energy. But the maximum fluctuation of energy in terms of areas. You have E value in terms of areas, that is mm square. But we need in joule. Joule means Newton meter. Okay. For that, we have to go for the scale, because we just drawn the available energy in terms of turning moment diagram. In turning moment diagram, we have turning moment, torque in the y-axis and theta in the x-axis. So we have in graph we have mm square, 1 mm in the x-axis, 1 mm in the y-axis. We have different scale. So just apply the scale here. For scale 1 mm into 1 mm. That here I have written mm square, which means mm into mm. That is in x-axis 1 mm means 3 degree. Okay, and we need radian. So I just multiply with pi by 180. The degree, 1 degree is equal to pi by 180 radian. Okay, for the energy calculation, we have to substitute radian, not degree. So I just take 3 into pi by 180. Next, in y-axis, 1 mm means 600 Newton meter. 600 Newton meter. If you multiply this, you will be getting the energy for 1 mm square. So Newton meter is also known as joule. For 1 mm square, 31.42 joule. Here we have 172 mm square. So just multiply with the 31.42. You will be getting the total maximum fluctuation of energy. Once you get the maximum fluctuation of energy, you can directly substitute this value in this formula, mk square omega square cs. Before that, we already know cs, coefficient of fluctuation of speed, is 0.03 because upper limit and lower limit is plus 1.5 minus 1.5. Take the difference, you will be getting 3%, so 0.03. Next, omega. You have mean speed, mean RPM value, so 2 pi n by 60 will be giving you the omega value. So just substitute here, you will be getting the mass value as 183 kilogram. This is the another numerical from flywheel. In the examination, you will be getting numericals from this one or previous one. Okay. In the next lecture, we will be discussing about the belt drives. Thank you.